So we talked about a lot of stuff. We talked about two-step equations. We talked about distributive property. We talked about combining like terms. We talked about fraction busting. All these different skills that go into solving equations, right? Now, the last little piece is how many solutions do we actually have? So there's 3 different outcomes we can come up with whenever we solve an equation, no matter what skills we're putting to use. Whether we're combining like terms, distributing, fraction busting, when we get to the end, we have one of these 3 outcomes. The first outcome is one solution. Everybody say one solution.
One solution.
So far, every problem we've done has had one solution. How do I know I have one solution? When I get something like x equals 2. Letter equals number. One solution. The only number that fits into this equation is 2, right? And every answer we've come up with so far is written just like this. B equals -4, C equals 2/7, letter equals number. That's one solution. We know that we have many solutions, and above that, I want you to write in parentheses that. Anyone know what that means?
Infinite.
Infinite, right? Technically, it's infinitely many solutions.
I don't know.
Okay? It's just an 8 on its side. So if you need to turn your paper 90 degrees and draw an 8, boom, that's how you do it. We know that we have many solutions when we see something at the end like this. 3 equals 3. When we get a number that equals itself, it could be anything. It could be 100 equals 100, -4 equals -4, 1/2 equals 1/2. If you've got the same thing on the left that you have on the right, then that means you have infinitely many solutions to that equation. And the last outcome is we have no solution at all. We know that we have no solution when we see something like 2 equals 3. Or a number equals a different number. Is 2 equal to 3? No. So if we end up, when we're solving everything step by step, we end up with a statement that's false, we have no solution to that equation. If we end up with a statement that's true, we have infinitely many solutions. And if we end up with what we've been ending up with, that's just one solution. That's the most common outcome, but we also have these 2 other identities as well. Think of an equation like a lock, right? What do you use to open a lock? A key. Okay, your PE locks may be a combination, but most locks you need a key, right? For example, let's think about my classroom door, right? I open my door with my classroom key, right? Do you think my classroom key opens Miss Karan's door?
Yeah.
Does it open Mr. Freethy's door? No. My key opens my door. That's one solution. Give me a thumbs up if that makes sense. Okay? Now, Mr. Michaud has a very special key. The master key. What door does Mr. Michaud's key unlock, Liana?
All of them.
All of them.
Also, is it possible for 2 different variables to represent the same number? So like a variable can equal a different variable?
So like x and y equaling the same thing?
Yeah.
Yes. Now, I'm glad you bring that up. All the equations we've been learning are univariate, meaning there's only one variable, right? But we will take a look at some equations in a couple days that have an x and a y, or an a b, and a c, and we'll figure out what to do with that. So that'll come up later for sure. But Mr. Michaud's key opens every single door, right? One key opens up all the doors in the entire school, right? That would be many solutions. His key opens many locks. My key opens one lock. No solution would be like my car key. Okay?
My key.
What door on campus would my car key open? None of it. Well, that's not on campus. That's in the parking lot. But whose classroom would my car key open? No one's, right? That would be no solution. Okay? So that's typically how I like to think about it. I don't know if that helps you or not.
Technically, no solution would be not having a key at all.
That too.
Yeah.
Yeah. Tyler, question.
Would a lockpick be many solutions?
Yeah. Yeah, if someone knows how to pick a lock, that could be many solutions, right? They open many doors. But those are our three outcomes. And this is a very, very simple way to remember what outcome is what solution. So let's take a look. With our first example, let's say we've got an equation that looks like this. -5 times 7 minus 8b plus b equals 7b minus 1.
Well, numbers would help that as well.
Don't get too freaked out. It'll be okay.
That's a whole lot of numbers.
You get an A in math class?
Huh?
You don't get a lot.
What? What'd you say?
That's a lot of numbers.
That's a lot of letters.
All right? Let's take a moment and get that example written down. Now, last week when we talked about the distributive property, we were
Wait,
doing
is that a B or a
expressions.
6?
Hold on. Last week when we talked about the distributive property, we were just dealing with expressions, right? So we didn't have to distribute, that's a B. We didn't have to distribute and actually solve. So we're going to use that same idea of the distributive property, which you guys are pretty comfortable with, right?
Yes.
Okay, and we're just going to implement it into our solving, right? So I'm going to split my equal sign first. Always, that's going to be the first thing we do. And what I want to do now is I want to clear out these parentheses. I want to distribute first so that I know what like terms I need to combine and what inverse operations I need to do on both sides. So what number am I going to be distributing here in this example? -5. Who am I going to distribute that -5 to?
-7. I mean 7 and
7
-8.
and -8b. Why aren't I distributing it to this b? Who could tell me? Christian, why not? It's not inside the parentheses. Right, again, inside the parentheses, that's all of you in this classroom. Here's me, the teacher, on the outside. I'm distributing a worksheet to everyone, but if you're not in my class, you're not getting a worksheet. You see what I mean? So we're going to leave this B alone for now. When we distribute this, we get -5 times 7, which is -35. And we get -5 times -8b, which is what? Positive 40b. We still got that plus b, and we've still got that equals 7b minus 1. I'm going to drop this down so we can focus on this. Go ahead and write off to the side there, distributive property, just so we know what we did. Now that I've distributed, is there any like terms I can combine on the same side?
Yes.
Yeah, what are my like terms?
40b plus b.
40b plus b equals 41b. -35 plus 41b equals that right-hand side. And what we did there was combined like terms. What can I do now? Yeah, Anthony, what's next?
You can move the 7 to the other side.
Move the 7b to the other side by doing what? Subtracting. Minus 7b minus 7b. What's 41 minus 7? I don't even know.
36.
36. Positive? Yeah.
Yeah, positive.
36.
No, not 36. Yeah, 34. Yeah. You got it. I thought it was 36 earlier too when I was writing it. Don't worry.
Miscalculation.
And those 7Bs go away. Am I going too fast?
No.
I feel like I'm going too fast.
No, you're not.
He is, man.
Stop telling yourself that.
It's okay. We'll take it slow. The next two will go fast. What do I want to do now? Add 35 to both sides. My 35s go away. I'm left with 34B equals 34.
Wow.
1.
Yeah, it's one.
Yellow pen.
34 divided by 34.
Good. Then we're going to divide both sides by 34. And then what do we get?
1.
34 over 34?
1.
Yeah.
1. B equals 1. Good. Now, how many solutions does this equation have? 1. What is the only key that's going to open up this lock?
1.
B equals 1. One solution. Just for consistency's sake.
No way, it took up the whole page for me.
Did you guys do proofs last year at all?
What?
What's that?
Good. I'll take that as a no.
What did I didn't hear you again.
So a proof? Proof? Proof?
No.
You didn't do proofs last year?
Who?
Okay, we will at the not poop. We will at the end of the school year. It's basically like every step you do in a problem, you have to justify it with a math theorem, postulate, reason.
So your work.
So God.
It's very annoying. It was my least favorite thing about math when I was in 8th grade. So it'll be fun. It'll be fun. We'll worry about that later. Everyone see how we got one solution? Give me a thumbs up if you see how we got one solution there. Perfect. I feel like we should do an easier one.
How do we get a number? Yeah, do an easier one.
How do we get a number that equals itself? I'm glad you asked. Let's figure it out with our next example. Negative 2 times the quantity of 1 plus 4n equals negative 2 minus 8n. This one won't take as much space, don't worry. Some of you already see right away what's going to happen. No, we're going to do it together. Just get it written down real quick. I'll see how you guys' notes are looking. What am I distributing here? What number is getting distributed? Negative 2, okay? Now take a look. Here's what happens. Negative 2 times 1 gives me negative 2. What's negative 2 times 4n? Negative 8n. Right away, what do you notice here? It's the same. The left side is the exact same expression as the right side. Okay? Now let's say we don't notice that. What would my next step normally be? Move my variable to the left. What's the opposite of minus 8n? Plus 8n.
Oh.
Okay. Take a look. What is 8n? Sorry, what is negative 8n plus 8n? 0. What is negative 8n plus 8n? 0 again.
So we get
I'm going to drop this down. What am I left with on the left-hand side?
negative 2.
What am I left with on the right-hand side? Is -2 equal to -2? Yes. So my answer is many solutions. My answer is not x equals -2 or n equals -2. That is not my answer. My answer is many solutions. Yes.
I have a question.
Sure.
What if it was a positive? One of them was positive. What is
-2 equals +2?
Yeah.
Is -2 the same as +2?
No.
No. How many solutions would that be then?
0.
None. It would be none. Right? No solution is a number equals a different number. A -2 is very different than a +2. Right? If I said I could either give you $100 or -$100, right? It's not the same choice. You'd take the $100. Otherwise, I'm stealing $100 from you. So that's many solutions. We get the same number on both sides. Okay? As soon as you see you've got the same thing on both sides, though, you know it's many solutions right away. One last one. What do you guys think is going to be next? You guys are good at guessing. Okay, let's take a look.
What the heck?
Oh my god.
That's longer than my hairline.
You guys, that'll be fine.
How fun.
No, fine, not fun. It'll be fine. It might be fun.
Yikes. No.
Depends on your idea of fun.
It's called sarcastic.
I think it's fun.
Sarcastic.
It's not fun to you?
It's alright.
This is how you calculate the length of his mouth.
Should be fun. Everyone got that written down?
Yeah.
Okay.
It would be fun if I didn't have to force you, if I wasn't forced you to come here every 7 days.
That's okay. That must mean it's fun on the weekend. What do I want to do first?
Distribute the 4.
Distribute the 4. I could combine like terms first too, but that's all right. I'm going to distribute first. Actually, I feel like we're ready. Let's do them both at the same time.
Yay.
Save ourselves a line. So I'm going to circle up my little X's on the left, and I'm going to distribute on the right. I'm going to do it at the same time, so don't get freaked out. Okay, relax, it's fine. Okay. -8x plus 10x gives me 2x. 4 times 1 is 4. 4 times x is 4x. And we fill in everything around it. I didn't throw anybody off by doing those both in the same step, right? Okay, good.
We threw me off.
Is there any more?
Yes.
Good. What else?
4x minus 2.
Good. 4x minus 2x gives me 2 x's.
2x.
Okay. All right, what do I want to do now?
Move the variable to the other
Move my
side.
variable to the left. What's the opposite of plus 2s? X, bless you.
Negative.
Minus 2x. Minus 2x.
Oh,
What is 2x minus 2x?
0.
0.
What is 2x minus 2x? 0 again. What's all that's left on the left?
7.
What's all that's left on the right? Is 7 equal to 4?
No.
Would you rather have $7 or $4? $7, right?
7,000.
There is
No solution.
no solution.
Yeah, you go to the worksheet now.
All right? No solution because 7 does not equal 4. What if we got 7 equals 7? What would my answer be then? Infinitely many solutions. We could just say many solutions. All right?
Worksheet time.
Sleep time.